Welcome back to video number 8 in our series on conceptual modeling. When I began this chapter, my intention was to concentrate on the conceptual modeling tool of the ER diagram. The author also discusses a different modeling approach than the ER diagram called the Unified Modeling Language, which is an approach that is used in quite a bit of software design. Even the author's presentation was brief and really meant to be introductory to the topic and not in depth the way the ER diagram discussion was. And therefore, I'm presenting this video to you as just an opportunity to introduce you to a different idea. I will not be testing on this, and there will be no check your knowledge questions on this, but I encourage you to watch it. It's not long, and get some idea about a different approach of conceptual modeling. The UML methodology is being used extensively in software design and has many types of diagram for various software design purposes. Unified Modeling Language is what UML stands for. And why don't we make Unified Modeling Language the mystery word for this video? Let's briefly discuss the basics of UML class diagrams and compare them with ER diagrams. In some way, class diagrams can be considered as an alternative to ER diagrams. This figure shows how the company ER database schema we looked at earlier can be displayed using UML class diagram notation. The entity types in the ER diagram are modeled as classes in the UML diagram. An entity in the ER model corresponds to an object in the UML model. In UML class diagram, a class, similar to an entity type and entity relationship, is displayed as a box that includes 3 sections. The top section gives the class name, similar to the entity type name. The middle section includes the attributes, and the last section includes operations that can be applied to individual objects of the class, similar to individual entities in an entity set. Top section name, middle section attributes, bottom section operations that can apply to the objects. Operations are not specified in ER diagrams. Consider the employee class in this figure. Its attributes are name, social security number, birth date, sex, address, and salary. The designer can optionally specify the domain of an attribute if desired by placing a colon followed by the domain name or description as illustrated by name, sex, and birth date. Name, colon, name, first and birth date, sex, male, female. A composite attribute is modeled as a structured domain as illustrated by the name attribute of employee. There you are. There's your composite attribute, first name, middle initial, last name. A multivalued attribute will generally be modeled as a separate class as illustrated by the location class. Here's location and then the name. Relationship types are called associations in UML terminology, and relationship instances are called links. A binary association, that's the binary relationship type, is represented as a line connecting the participating classes or entity types and may optionally have a name. A relationship attribute, called a link attribute, is placed in a box that is connected to the associations line by a dashed line. In UML, there are two types of relationships: association and aggregation. Aggregation is meant to represent a relationship between a whole object and its component parts, and it has a distinct diagrammatic notation. In that last image, we modeled the location of department and the single location of a project as aggregations. However, aggregation and association do not have different structural properties, and the choice as to which type of relationship to use is somewhat subjective. In the ER model, both are represented as relationships. UML also distinguishes between a unidirectional and a bidirectional association, or aggregation. In the unidirectional case, the line connecting the classes is displayed with an arrow to indicate that only one direction for accessing related object is needed. If no arrow is displayed, the bidirectional case is assumed, which is the default. For example, if we always expect to access a manager of a department starting from the department object, we would draw the association line representing manager's association with an arrow from department to employee. In addition, relationship instances may be specified to be ordered. For example, we could specify that the employee object related to each department through the works for association should be ordered by their salary attribute value. Association, or relationships, association names are optional in UML, and relationship attributes are displayed in a box attached with a dashed line representing the association aggregation, such as start date and hours that we saw in our ER diagram. The operations given in this class are derived from the functional requirements of the application, as we discussed earlier. It is generally sufficient to specify the operation names initially for the logical operations that are expected to be applied to the individual objects of a class. As the design is refined, more details are added, such as the exact argument types or parameters for each operation, plus a functional description of each operation. UML has function descriptions and sequence diagrams to specify some of the operation details, but these are beyond the scope of our discussion. Weak entities can be modeled using the construct called qualified association or qualified aggregation in UML. This can represent both the identifying relationship and the partial key, which is placed in a box attached to the owner class. See it there? This is illustrated by the dependent class and its qualified aggregation to employee. The partial key dependent name is called the discriminator in UML terminology, since its value distinguishes the objects associated with or related to the same employee. Qualified associations are not restricted to modeling weak entities, and they can be used to model other situations in UML. This section is not meant to be a complete description of UML class diagrams, to say the least. Rather, it illustrates one popular type of alternative diagrammatic notation that can be used for representing ER modeling concepts. Well, that concludes video 8, which was an introduction to UML from our series on conceptual modeling. There is no check your knowledge for this video, and there'll be no questions on the final exam pertaining to unified modeling language. So take a break. When you're ready, come on back for the concluding video in our series on conceptual modeling.